Hello everyone and welcome to the third in our series on object-oriented programming. Object-oriented programming is when programs are written in terms of objects and classes, and this differs from procedural or functional programming, where programs are written as a collection of functions, or sometimes termed modules. Previously, we learned that objects are unordered collections of properties, meaning data, variables, sometimes termed fields, and/or methods, by which we mean functions. And this means that properties are things that an object has, for example, name, age, height, and weight, whilst methods are things that an object can do, for example, run, swim, fly, and so on. We also learned we can create blueprints for objects called classes, and we learned that objects can therefore be instances of a class, and when an object is created as an instance of a class, it is said to have been instantiated. As an example of objects and classes, Lassie is an instance of the dog class, and there is only one Lassie, but there are many dogs, and this is the correct relationship between objects and classes. In the previous video in this series, we also learned that inheritance is when one class inherits properties and methods from another class, that the inheriting class is called the subclass or child class, whilst the other class, the class which is being inherited from, is called the superclass or parent class. We learned that a subclass is a more specific version of the superclass. An appropriate example of this is the dog class being a subclass of the mammal class, and we would say that the mammal class is the superclass of the dog class. We learned that this allows us to create hierarchies of classes, and in this example, the mammal class inherits from the animal class, and the human class in turn inherits from the mammal class. Notice that the mammal class has all of the same members as the animal class, and the human class has all of the same members as the mammal class and the animal class. And we can say that the human class inherits members from the mammal class directly and members from the animal class indirectly. We saw what this looks like in pseudocode. We have an animal class with the properties height and weight. We have a person class that extends, meaning inherits from, the animal class with the property name, and we create a new instance of the person class, and we know that this instance of the person class will have a name property and a height and a weight property, with the height and the weight properties being inherited from the animal class. If this all sounds a little daunting, check out the previous two videos in this series where I cover these concepts in much further detail. However, if you're comfortable with these concepts, we'll move on and look at method overriding. Method overriding can be best understood as the answer to the question, what happens when a class inherits a property or method with the same name as one of its own properties or methods? Here we have an example in pseudocode which raises this question. We have two class declarations, the mammal class and the human class. Both have a move method. Notice that the human class extends over the mammal class and will inherit all of its members. Underneath our class declarations, we create an instance of the human class, called me. We then call the move method, which is a member of the me object. But which move method will this be? Will it be the move method as declared in the class declaration for the human class, or will it be the move method as declared in the class declaration for the mammal class? The answer to what happens in this scenario depends on which language or implementation is being used. Sometimes this causes an error and is not allowed. Other times, the method belonging to the subclass overrides or replaces the method of the superclass. If this is allowed, the language or implementation is said to support method overriding. In many object-oriented programming languages, the subclass contains a reference to the superclass, often by way of the super keyword. In languages that have good support for method overriding, methods that have been overwritten can still be accessed by use of this reference. To illustrate a use of the super keyword, we will return to our previous example with some new modifications. The mammal class is exactly the same and still has one member, the move method. I have also added the car class with the method drive. I have also updated the human class. It still extends over the mammal class, but it also has the new properties car which is an instance of the car class from the previous slide, and has car keys, which is a Boolean true or false value. The move method is updated, and here we will make use of the this keyword we have seen in previous tutorials. The this keyword in a class declaration refers to the object which has as one of its members that method because it is an instance of that class. Underneath our class declarations, we create an instance of the human class called me. We then set the hasCarKeys property of the me object to true and invoke the move method, which is a member of the me object. When this method is called, the method will check the hasCarKeys property of the me object, and if it is set to true, then the method drive of the car property of the me object will be invoked. Else, if me does not have car keys, then the move method of the parent class of the human class is invoked, because me is an instance of the human class, with its parent class or superclass being the mammal class. This in effect means that if an instance of the human class has their car keys and they are asked to move, they will drive using their car. Otherwise, they will move in the same fashion as other mammals, by putting one foot in front of the other. The good thing about method overriding is that it allows us to control when a subclass should or shouldn't behave like its superclass. And it allows us to reuse method names in subclasses while still maintaining reference to the original method via the super keyword. And that's it for this video. As always, rate, comment and subscribe. Questions, comments and criticism are always welcome. And in our next tutorial we will be looking at the concept of encapsulation. So hope to see you there.